Hello students, a pleasing welcome to all. I am really very happy to meet you all through this video session. This is Gopal from Department of Chemistry, Bharathidhasanar Matric High Secondary School, Arakkonam. Today we are going to see 11th Chemistry, first unit. Our today topic is Stoichiometry calculations. So before that, we already know about the stoichiometry. The stoichiometry helps us to balance the equation, and by balancing this we can know the moles, molar mass and volume of the reactants and the product. So the first step is, after understanding the question, we need to write the balanced equation. So first step is write the equation. First step is to write the equation. After we write the equation, we can balance the equation. So second step is to balance the equation. This is our second step. So students, after balancing this, we can find the three terms. First one is the number of moles, next one molar mass, the molar mass, and next one the volume. So whatever we need, we can calculate this. So stoichiometry calculations only contains the problematic questions. From this question, you can write the equation first and balance the equation in this next step, and third one you can find the moles, molar mass and volume of the reactants and products. So can we go to the first question? How many moles of hydrogen is required to produce 10 moles of ammonia? This is our first question. So first understand the question, in which the product is ammonia, because to produce the product ammonia is represented here. And how many moles of hydrogen means they asked the hydrogens, how many moles of hydrogens required in reactants, because hydrogen present in the reactant. So hydrogen produces ammonia. You already know that when the hydrogen can produce ammonia, when hydrogen reacts with nitrogen, then only it can form ammonia. So hydrogen reacts with nitrogen to form ammonia. So this is a reaction. So first step is to write the equation. Now we write the equation, and our next step is to balance this equation. When we balancing this, you can see 3 hydrogens in the right side. So in the left side we have only 2 hydrogens. So the common number for in between 2 and 3 is 6. When I write 2 in front of ammonia, I can find the number of molecules for hydrogen is 6. 2 NH3, then only we can get 6 hydrogens. In left side we have H2. When I write 3 in front of it, I can get 3 into 2, 6 hydrogens. So the hydrogens in the left side and right side are balanced. Next one nitrogen, 2 nitrogen in the left side and 2 nitrogen in the right side. So nitrogen also balanced. This is the correct balancing equation. After balancing this, we can find the number of moles. They asked the moles, how many moles of hydrogen to produce 10 moles of ammonia. So 10 moles of ammonia we want to produce. First students, now note the moles required to produce ammonia. Actually 3 moles of hydrogen reacts with 1 mole of nitrogen to produce 2 moles of ammonia. So this is the information is obtained from this equation, and we want to produce 10 moles of ammonia. So to produce 10 moles of ammonia, how many moles of hydrogen is required? This is the question. So you note, first we need hydrogen we need to find the moles of hydrogen to find the moles of hydrogen. Let us see, 2 moles of ammonia required 3 moles of nitrogen. So, first information is 2 moles of ammonia requires 3 moles of hydrogen. So, we need to produce 10 moles of ammonia. So, 10 moles of ammonia requires how many moles of hydrogen? So, this is a question writing formation. After that you can see 1 2s are 2, 5 2s are 10. So, 3 into 5, the answer 15 moles of hydrogen is required in this reaction. So, this is the answer. So, the answer is 15 moles. So, let us see students, first step is to write the equation and our second step is to balancing this equation. After balancing, we note the moles, 3 moles of hydrogen, 1 mole of nitrogen and 2 moles of ammonia. And see one thing, after we write the moles, we want to write our required moles of product. Our required mole of ammonia is 10. For 10 moles of ammonia, how many moles of hydrogen required? This is the question. So, let us see the calculations. 2 moles of ammonia requires 3 moles of hydrogen. So, 10 moles of ammonia requires how many moles of hydrogen? The answer as 15 moles of hydrogen. So, this is the answer. So, in this question, we found the number of moles. As like we can found the another concept. Let us see the amount. So, our next question is calculate the amount of water produced by the combustion of 32 grams of methane. So, let us understand this. The question is made up of the reaction combustion of methane. So, first step is to write the equation. The equation is for combustion of methane. So, the equation contains methane as the reactant. On the combustion, it is heated in presence of air. So, the air contains oxygen reacts with the methane. So, CH4 reacts with O2. On combustion of methane, we can get the products. One is carbon dioxide and another one is the water molecule. So, this is the correct balanced equation and we need to balance this means you can see number of carbons in the left side and right side are same and number of hydrogens. In left side we have 4 hydrogens, but in right side we have only 2 hydrogens. So, to balance this I write 2 in front of H2O. So, look at here, now the hydrogens also balanced. Let us see about the oxygens. Oxygen in the right side is 2 plus 2, 4. In left side we have only 2 oxygens. So, write 2 in front of oxygen. You can get a balanced equation. So, all the atoms in left side is equal to all the atoms in the right side. This is balanced equation. To find out the moles, let us see, the CH4 contains moles 1, the oxygen contains 2 moles and carbon dioxide contains 1 mole, water molecules contains 2 moles. Let us see students, in which the 1 mole of methane produce 1 mole of carbon dioxide and 2 moles of oxygen involves in produce 1 mole of carbon dioxide. Additionally, 2 water molecules moles are eliminated. Let us see in this reaction. In the question, they discuss about the product water and the reactant methane. So, only you consider the methane and water. The information given in this question you can see, for methane they give 32 grams. So, methane they give as 32 grams. If methane 32 grams means how much amount of water can be produced? This is the question. So, we need to find amount of water. Let us see, in this question they do not consider about the moles, they consider about the mass. So, you need to convert these moles into the mass. How can we convert moles into mass? Let us see, for methane I found the molar mass. it contains carbon and hydrogen. One carbon contains 12 gram. Hydrogen, one hydrogen contains 1 gram. We have 4 hydrogens. So, total mass is 4 gram. So, 12 plus 4, 16 gram is the molar mass for methane. So, for methane, we take 16 gram of methane. 1 mole of methane contains 16 grams. Now, find out the molar mass for water molecules. You already know that the water molecules made up of hydrogen and oxygen. The hydrogen contains weight 1, now oxygen contains the weight 16, and we have 2 hydrogens. So, additionally 1 hydrogen present here. So, 16, 1 plus 1, 18 gram is the molar mass for the water molecules. But look here, we have 2 moles of water molecules. So, 2 into 18 gram, totally 36 grams of water molecules present here. Now, see by the amount, 16 gram of methane can produce 36 gram of water. So, if 32 gram of methane we takes means how many water molecules can be produced? We can find this by, now I write the amount of water as answer. So, see here 16 gram of methane can produce 36 gram of water. So, 32 gram of methane produce how much amount water is the question. So, to find the answer, let us see 116 or 16, 2 16 or 32. So, 2 into 36, 72. 72 grams of water molecules can be produced by 32 grams of methane. So, the answer is 72 gram. It is simple calculations. So, by stoichiometric calculation, after we balancing the equation, we can find the number of moles and we can find the amount of the substance. So, this is the calculation method. So, stoichiometric calculation includes how can we find the moles and volumes and number of molecules. So, students, by this we can know the mole concept. Mole concept also give the same matter. For example, in a mole concept, the number of molecules are 6.023 into 10 power 23 molecules for 1 mole, and for 1 mole of any gas molecules, the volume is 22.4 liters. So, mole concept also gives the number of moles, number of molecules and volume with molar mass also. So, mole concept is closely related to the stoichiometric calculations. You do these calculations. If you have any doubts and clarification, you can contact me. This study material contains a book back and additional questions, and the answers are given in stepwise, important formulas and definitions also given in the study materials. Okay students, thanks for making time to watching this video. Thank you.